Hey all, this is Alan with Bothell STEM Coach, and today we are doing some more AP Physics 1 free response questions. And we are going to be looking at some momentum questions. So as usual, I recommend that you pause the video, try to do the problem on your own, and keep watching it after you've attempted the problem. So as shown above, a 0.2 kilogram mass sliding on a horizontal frictionless air track with a speed of 3 meters per second. When it instantaneously hits and sticks to a 1.3 kilogram mass, initially it rests on the track. The 1.3 kilogram mass is connected to one end of a massless spring, which is a spring constant of 100 newtons per meter. The other end of the spring is fixed. Determine the following for the 0.2 kilogram mass immediately before impact: its linear momentum and its kinetic energy. So its momentum is just m times v. So it's 0.2 kilograms times 3 meters per second. And that is 0.6 kilograms meters per second. So that is momentum. Its kinetic energy is equal to 1/2 mv squared. 1/2 0.2 kilograms times 3 meters per second squared. 9 times 0.1 is 0.9 joules. Okay. Determine the following for its combined masses immediately after impact: the linear momentum, kinetic energy. Now, what's conserved during the collision is momentum, not energy, because this is an inelastic collision. Well, because they're stuck together, but I mean, in principle, momentum's always conserved unless there's an outside force. Energy not necessarily conserved. So the P has to be the same, right? But I want to know what it's equal to mv, which is the mass of them together, which is 1.5 kilograms, times their velocity. So the velocity of the combined mass would be 0.6 divided by 1.5, and that would be 0.4 meters per second. So together they're moving. Now, that's just what its velocity is, but what we're asking for here is its kinetic energy, which is 1/2 mv squared. 1/2 1.5 kilograms, because they're both moving together. V squared, that's 0.4 meters per second squared. 0.16, 0.08, 0.12. No, that can't be right. Oh yeah, it is right. 0.12 smaller than 0.9, duh. Okay. After the collision, the two masses compress the spring as shown. Determine the maximum compression distance of the spring. So all of this kinetic energy is going to go and go. It's going to slow down because the spring's going to keep pushing back on it until all of its kinetic energy is expended and all the energy went into the compressing the spring. So the energy in the spring is 1/2 k delta x squared. That has to equal 0.12 joules. Now delta x then would be 2 times 0.12 joules divided by k, and then I do a square root, and they told us k was 100. I get 0.04849 meters. Okay, and that's it. Hope you found that helpful. I'll see you guys in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content, and see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.